Next example we take differentiate tan 2x with respect to x from first principles. They may give tan 2x or any trigonometric function with different this one 2x or 3x or ax, like that they give it. Even that method is same. Only thing is a little trigonometry you have to use and bring it to the form sin theta by theta, theta tending 0 is equal to 1. Let y is equal to tan 2x. Let delta x be a small change in x and delta y be the corresponding change in y. So as usual we write y plus delta y here because there is a small change in x. Tan here you must be very careful. Don't write 2x plus delta x but 2 into x plus delta x. So below that you write y is equal to tan 2x and subtract as usual delta y is equal to tan 2x plus 2 delta x minus tan 2x. Then divide both sides by delta x and take limits as delta x tending to 0. First divide by delta x, a little space we leave and then write tan 2x plus delta x, 2x plus 2 delta x. You see what we have done here, 2 times of x plus delta x is there, 2x plus 2 delta x minus tan 2x by delta x and write limits both sides. Limit delta x tending to 0. Here also limit delta x tending to 0. By convention, left hand side is written as dy by dx as a symbol is equal to limit delta x tending to 0. Tan c minus tan d, there is no formula, so tan is written as sin by cos. Sin 2x plus 2 delta x by cos 2x plus 2 delta x minus sin 2x by cos 2x whole divided by delta x. Now we take the LCM, limit delta x tending to 0, sin 2x plus 2 delta x into cos 2x minus cos 2x plus 2 delta x into sin into sin 2x whole divided by, and that LCM together with this delta x, cos 2x plus 2 delta x minus into cos 2x, cos 2x. So numerator sin a cos b minus cos a sin b, sin a minus b. So it is equal to limit delta x tending to 0, sin 2x plus 2 delta x minus 2x, that is the expansion of sin a minus b. So divided by delta x into cos of 2x plus 2 delta x into cos 2x. Now in the numerator, this 2x and minus 2x cancel, sin 2 delta x is there. So this can be written as a limit delta x tending to 0, sin 2 delta x, sin 2 delta x by delta x. This cannot be this is not in the form sin theta by theta, so 2 delta x is necessary. So when you divide by 2, so you have to multiply by 2 and then put a bracket here. The rest of them write as they are. Cos 2x plus delta x into cos 2x. And this step is important. Here only delta x is there. How we got 2, you may think. Multiply by 2 and divide by 2. So that this becomes sin theta by theta. That is equal to 1. Sin theta by theta, is equal to 1. Theta being 2 delta x. The rest of it you see wherever delta x is there you write 0. Cos 2x plus 0 into cos 2x. And that is nothing but 2 divided by cos square 2x. And that is 2 into 1 by cos square 2x is what? Secant square 2x. Secant square 2x. So this is dy by dx. We take one more example, that is third. Differentiate secant ax with respect to x from first principle. Secant ax, 2x, 3x like that. Differentiate secant 2x, not 2x, ax with respect to x from first principles. Now we take y is equal to secant ax. Let delta x be a small change in x and delta y and delta y be the corresponding change in y. So y plus delta y is equal to secant a plus a into x plus delta x. A into here a into x plus delta x. Here you must be very careful. You don't write ax plus delta x but a into x plus delta x. And below that you write y is equal to secant ax. Then subtract delta y is equal to secant a into x plus delta x minus secant ax. So as usual we say divide both sides by delta x and take limits as delta x tending to 0. So limit delta y by delta x tending to 0 is equal to limit secant ax plus a delta x. Now I remove the bracket minus secant ax and I divide by delta x and then delta x tending to 0. So this the left hand side is what? Dy by dx. Right hand side secant c minus secant d, there is no formula. Secant is written as 1 by cos. Limit delta x tending to 0 1 by cos ax plus a delta x minus 1 by cos ax whole divided by delta x. Now take say LCM. Limit delta x tending to 0. Here cos ax minus cos ax plus a delta x by LCM and together with delta x. Cos ax plus a delta x into cos ax. Now numerator now is what? Cos c minus cos d, 2 sin c plus d by 2 sin d minus c by 2. So limit delta x tending to 0, 2 sin c plus d by 2, ax plus a delta x by 2 into sin d minus c by 2, ax plus a delta x minus ax by 2, and as usual denominator is there, that is delta x into cos of ax plus a delta x into cos ax. Now here this ax and minus ax cancel, a delta x by 2 is there. So this step is important, that is what you have to readjust the whole problem into sin theta by theta form. So sin ax plus ax is what? 2ax. Sin 2ax plus a delta x by 2 into are divided by the things cos of ax plus a delta x into cos ax into bracket. Here sin now sin a delta x by 2 is there, by delta x is there with us, and by 2 also is there. Already that numerator can be brought to the denominator, but this cannot be brought into sin theta by theta form. So what we do, we multiply by a and divide by a. Here I divide by a and here I multiply by a. So this is limit delta x tending to 0. Now limit is not necessary. We write wherever delta x is there 0. So a into sin 2ax plus 0 by 2, that means what? 2 and 2 cancel, and denominator is what? Cos ax plus 0 into cos ax into 1. That 1 is what? Sin theta by theta, theta to 0 is 1. Here 1 by cos ax is what? Secant ax, and a is already there. A secant ax into sin ax by cos ax is what? Tan ax. This is dy by dx. In the same manner, some examples can be worked out by using the first principles.